looking at 812 still. Let's look at number 2, talk about recursive defined sequences. So a(n plus 1 equals 1 over 1 minus a(n), where a1 equals 0. So in any sequence, just a little refresher, a(n) is this term, the next term is a(n plus 1, the next term is a(n plus 2, the next term is a(n plus 3. So, you know, if this is the first term, this is the second, this is the third, this is the fourth. It's really kind of all we need. So if I know the first term, then I can find the second term by putting in 1 over 1 minus the term before n plus 1, which would be a1. Now I'll write it as a1 once. If you don't write it as that 1 over 1 minus 0 right away, that's fine. So what happens? a2 is 1. So if I want to find a3, I use 1 over 1 minus a2. a2 was 1. And what happens here when we have 1 over 1 minus 1? It ends up being undefined. So not a great first example, but let's look at the next one. m n plus 1, so the next term is equal to 3 times the term before it minus 2. And if our first term is negative 1, we just put that there. So m2 is equal to 3 times negative 1 minus 2 equals negative 9. m3, now we can start seeing the pattern. 3 times negative 9 minus 2 is negative 33. It's going to get kind of big pretty quick. m4 is equal to 3 times negative 33 minus 2, which is going to be 105. And finally, m5 is 3 times negative 105 minus 2, negative 107 times 3, let's call that negative 321. So we've got our 5 terms written out. We use the term before it. The 1 goes in, the 9 goes in. You can definitely see that. Let's try one more. P n plus 1 equals 5 minus Pn squared, where P1 is 1. So P2 is equal to 5 minus 1 squared. It's going to be equal to 4. P3 is going to be 5 minus 4 squared, negative 11. P4, 5 minus negative 11 squared, negative 116. P5 is going to be big again. P5 is going to be 5 minus negative 116 squared, which I think is 13,456. So 5 minus that would be 13,451 negative. Just like the last problem, you can see where the 1 went in. We can definitely see our progression here. And let's look at number 3a2. B n plus 1, the next term, is equal to the term before it minus 5, where our first one is 3. So B2 is 3 minus 5, which is negative 2. B3 is negative 2 minus 5, which is negative 7. B4, negative 7 minus 5, which is negative 12. B5 equals negative 12 minus 5, which is negative 17. And then it asks us to find a formula for the sequence that is not recursive. So we want to find our AN formula. What's our pattern? We are subtracting 5 each time, which if we look at this, that's what it tells us. We take the term before it, and we subtract 5 to get the next term. Then we subtract 5, get the next term. That's what it's telling us. So our formula is A1 plus D times n minus 1. And let's see if that works. Is AN equal to 3 minus 5n plus 5? Is AN equal to 8 minus 5n? Does that work for our first term? If I put a 1 in, is A1 equal to 8 minus 5? Yes. So there's our formula. And we could totally leave it like this. Either one would be fine. Kind of going back to those Algebra 2 formulas. All right, 812 done.